Alright guys, welcome back to the another video. In this video, I'm going to talk about beginning with GeoAI. It's a lot more easier than you think. So this topic is from June 7th, 2024. This is the part of Geo series organized by OSGeo Nepal and NGES. And I'm Tech Chetri. If you don't know me, I'm the member of OSGeo Nepal and I'm currently studying geoscience at University of Calgary, Canada. And geospatial thing is always like interesting to me, and I uh, is an interest. I have developed several open source packages, and then I have also created the YouTube channel named as GeoDev. Okay, first of all, so to get start with GeoAI, let me talk about what is GeoAI. GeoAI is the branch of artificial intelligence which is built to solve the spatial problems. For example, like the satellite imagery analysis or the vehicle counting system. Those are all the example of GeoAI. I'll talk about its example later in the presentation, but for this slide, so let me talk some of the basic things. So it also helps to automatically extract the information, classification, and object detection from datasets such as imagery, video, point cloud, or the text. You can see it in the right side figure as well. So there are like several overlap between GIS, imagery, or the spatial data, and then the artificial intelligence. And the intersection of all these three fields is the GeoAI, which is also known as geospatial artificial intelligence. And talking about AI, so artificial intelligence is the very big topic in which we have like subclasses like machine learning, and inside machine learning we have like deep learning, which is the which works like the our brain. It's like the neural network, and the other side we have spatial analysis problems such as vector analysis, imagery or raster analysis, spatio-temporal statistic, network analysis, modeling, 3D analysis, real-time analysis, and so on and so forth. And yeah, to solve this kind of spatial problem, we can use the artificial intelligence, and when we combine this together, it's the geospatial artificial intelligence. To talk about Geo AI evolution, so actually it started around mid 1960, and by that time it has very limited local intelligence and limited resources. By that time it exposed as the maximum likelihood classification, nearest neighbor, and kriging was introduced. That time it has like 0.4% of the world population has access to internet. Actually that time, actually only in USA there was access to the internet and limited technology due to storage and computing power. And around the same generation, arc info was introduced for the GIS product in 1982. And then we move to the second generation of GeoAI, which is also known as early enterprise and web era. In that era, we have support vector clustering, geospatially weighted regression, GWR was introduced. It was from 2000 to late 2000s, around 2008 9. And during that time, the 16% of the world population has access to the internet. And after that, in 2010 to 2019, we also call this era, this generation is the big leap, because in this particular generation, AI has revolved so rapidly, And during that time we had ImageNet, which was introduced in 2009. And later lots of imaging computation, like computational imaging analysis things such as convolution neural network was introduced, and then also billion of dollars was invested in research related to machine learning and deep learning. In this time, actually there was a rise of big data and cloud computing. PC became smaller, cheaper, and exponentially more powerful. Advancement in GPU and invention of SSD. Actually, this time 45% of the world population has access to the access to the internet. And also during this time Google Colab was released. The actual year was 2017, and it's the uh, actually go-to resource for many developers still. And this time data creation was like 100 GB per day in 1992, 100 GB per second in 2002, and then 50,000 GB per second in 2018. That means we created so many data. And then uh, due to like availability of large volume of data, we have large spatial analysis, I mean simply the artificial intelligence analysis. And yeah, that's how we enter to the fourth generation. In the fourth generation, it's also called frontier of intelligence, and it started from 2019 to now. And during this age, the generative AI was introduced, and then people are now currently trying to build the earth foundation model as well, natural language processing. And then this time also like chat gpt was introduced, and then it minimized the role of machine learning, but maximized the like role of deep learning and generative ai. And during this time 60% of the world population has access to the internet. Okay, talking about GeoAI examples. So the first one is, of course, we can use it to create the land use land cover map. Of course, we can predict the future land use land cover map as well. And second example is like also like the forest loss or the deforestation rate or the fire like forest fire things. We can easily track those things, map those things using artificial intelligence. Also we can detect the object from like satellite imagery. For example, in this particular figure you can see that we are detecting the aeroplanes from like satellite imagery. Of course, we can detect like big animals like elephant or whales from the satellite imagery as well. And another interesting work is like, of course, there are like road detection and building detection kind of work going on. And this is also the another good example of like machine learning and deep learning. And also some of the application include like clustering or finding the pattern in the data set. So in this case, for example, categorizing the similar kind of vehicle or the similar kind of land cover in a map, so we can do lots of things. Okay, here talking about GeoAI, there are basically two major components. One is geospatial data, uh, and another one is artificial intelligence algorithm. So in the geospatial data collection, so we have like information related to Earth surface and environment and its infrastructure. For example, we have large volume of data, millions of petabyte of data in imagery and GPS and GIS databases. And in the artificial intelligence algorithm selection part, so we can do the prediction, classification, and generate the valuable insight from artificial intelligence. And it include machine learning, deep learning, and recently there has been an advancement in the deep learning field, which is also known as generative AI. And of course, most of my viewer are already familiar with the geospatial data collection. So in this particular presentation, I'm more focused on the artificial intelligence part, not the geospatial data collection part. Okay, talking about AI, so let me talk first about the machine learning thing. Of course, in machine learning, we have basically three major type of machine learning. So supervised, unsupervised, and reinforcement learning. Reinforcement learning is useful for like au- automatic like learning, ro- training the robot, and then real time decision, game changing, and then learning tasks. For example, based on our searching pattern, it will try to find what product we might like. So those things. And unsupervised learning, of course, in unsupervised learning we have clustering and dimension reduction. And in clustering, of course, we try to find the similar kind of data and then combine it together, and later on we try to see which cluster represent what kind of information. And but in the supervised learning, we have classification and regression tags. This reinforcement learning and unsupervised learning are not that significantly used topic, but the supervised learning is widely used, and then it's more applicable in lots of like GeoAI field. I'll show you the example later as well. But you just need to remember that in supervised learning we have classification and regression. The classification means like try to classify your try to classify the class of your data set, input data set. In regression, we try to get the exact value of your input. For example, based on the like weather conditions today, we can forecast the temperature of tomorrow. Then it's more about regression. I'll talk more about this thing later as well. First of all, let me talk about supervised versus unsupervised. As I said before, in the unsupervised, we try to find the pattern, I mean the cluster between the data. So here in this example, we can see two different clusters, and then some of the random like points which doesn't matter. But in the supervised learning, so we try to assign the class first, based on our knowledge. We like classify the values like the orange color and then blue color, and later we add the unknown variable, and then we try to somehow create the boundary between them, and then based on that particular boundary, which is generated by machine learning or deep learning, and then based on that boundary we try to classify the unknown values, whether it's belong to class A or class B, class 1 or class 2. Yeah. So let me dive more into the supervised learning. So in the supervised, as I said before, there are two types of supervised learning: regression and classification. And in regression, of course, we try to find the actual value of the input data set. For example, what will be the temperature tomorrow, 84 Fahrenheit, right? But in classification, we only try to classify the temperature into two category or the three category, like cold, normal, or hot. That's all. So we will have some threshold value, and based on that threshold we try to classify cold or hot or normal, um, or maybe in the in term of like geospatial field. For example, we can classify the pixel value, whether this pixel value belong to the urban area or the uh, forest or the agriculture area. So all right, so that's all about like a basic overview of all the like machine learning algorithms. So let me get into the input data set now. So for the input data set, so we have basically three major requirement in the input data set for all the machine learning problem. So first one is we should not have any missing value in the data set, otherwise it might create problem while training the model. And the thing is data should be in numeric format. For example, if there are multiple classes, then we should represent the class by number 1 2 3 4 or something. Yeah, and the thing is data either stored in numpy array or in pandas data frame. So just remember these three conditions whenever you try to run your model. And the training process for the machine learning is like simply you need to like input the training data set, and then also you need to input the expected output, and based on that your computer will try to find the pattern between this input and output based on your selected algorithm, and it will execute the program, and then you can do the prediction for the other new data set. And to talk more about these training processes, I have created this flow chart. So this is the like basic flow chart for all your machine learning or deep learning work. First of all, you'll have your input data set and then expected output, and after that you pass that data set and then do the cleaning and pre-processing. In this step you might need to do like enhancement in your data set or remove non values, or maybe like normalize your data set, shuffle your data set, right? And after that you need to train your model, machine learning model, and then do the prediction. And if you feel like it's inaccurate prediction, then you need to do the parameter tuning, and sometime you might also need to add more data set to your model, and then again do the prediction and repeat this circle whenever you have like satisfactory accuracy. And after that you can stop and then find out the model, and then based on that model you can do prediction for the newer data set. So this is the basic workflow of machine learning. Just remember this workflow because I'm going to again talk about it during my like demonstration. So yeah, basically in all algorithm we try to follow this pattern. And yeah, it looks very clean and then simple, but the little bit issue part is ML training model. So we don't know like which model to select. So there are so many models available in the internet. For example, we have linear regression, logistic regression, LSTM, decision tree, random forest, and k-mean clustering, KNN, ANN, and so many, right? So I suggest you to like take few and then try to like learn them. uh, Always there is a like challenge. You need to find out like which model work for what kind of task. For example, random forest and decision tree are really great for the classification tasks, and they work with classification. But recently the same algorithm was introduced to do the regression tasks as well. And then linear regression is very useful for the regression tasks, not for the classification. You just need to remember what kind of algorithm is useful for which specific task. For example, if you cannot like use k-mean clustering for the classification or the regression tasks, because k-mean clustering is particularly useful for the unsupervised learning, and then it helps to make the cluster of your data set, not the like class of your data, or not the like exact value from your input data set. So you need to remember that which model work for what kind of task. Of course, as I said before, so algorithm selection part is a little bit like you need to little bit explore the algorithms, and then you need to select the appropriate algorithm. It's like challenging to select the algorithm for specific geospatial tasks. So and the thing is also like in the geospatial field we have data complexity. Of course geospatial data can be complex, diverse and voluminous, posing challenge in data pre-processing, integrating and future extraction. Of course it's different from normal data set because it has like certain metadata like the locational information, so we need to preserve that throughout the training and predicting stage. So yeah, that's why these two are the like major challenges with GeoAI. But when you start working with the geospatial data, then you'll figure out on your way. Okay, so let me talk about some of the basic problem with the beginner. So of course if you I have seen so many like data scientists, I mean the so many peoples who directly dive into the deep learning instead of learning like data analysis or machine learning part first. So yeah, which is wrong. So I always suggest to like read a little bit about data analysis before starting machine learning or deep learning. And of course deep learning is a lot more complex than the machine learning, so you also need to understand the machine learning first. And the thing is of course everyone wants to learn Python, but no one want to learn math. And then everyone want to be a data scientist. And I have seen so many people like they simply start learning Python and then they simply follow some of the tutorials, but they don't know the logic behind that algorithm or the like the method. So which is also the problem. And the thing is like before understanding the theory they directly dive into the framework, and then they say why it's so difficult. Because of course without knowing the actual theory all the algorithm are difficult. And the thing is actually this is also the part of like machine learning fault. So if you the uh, train your model on some data set, then everything whatever has the similar like features, it says that same feature. For example in this figure, so this baby is seeing daddy in each of the picture, which is not good. To solve this kind of problem you need to understand your data first, and then you need to do some of the like visualization using your data. And then you might need to like enhance your data, normalize your data. So you need to like work with your data before you start training your model. All right, so then how to get started with GeoAI? So this is the most important slide from this talk. So I always recommend you to like follow this step to get started with the geospatial artificial intelligence. So first of all, I highly recommend you to learn the math. So simply you need to understand what is mean, median, mode, or the standard deviation. So some of the like very basic math uh, concept, so you need to understand those. And after that you can learn Python, or you can learn math and Python both simultaneously, parallelly. um, there is no problem. And after that you need to know like how to apply mathematics in Python. So in order to apply mathematics, so there are very great libraries like numpy and pandas. So you need to get start with these libraries, and then you need to understand at least like how to calculate the standard deviation, how to calculate the mean using this library, because it's very simple and you don't need to like write the whole formula. This library has already like methods to create the your basic mathematic formula. And after that I highly recommend you to know the possibility and limitation of machine learning. For example some of the time people ask that some of the impossible things might be people think that some of the impossible things might be possible with the machine learning, and without being data or without being like some of the uh, training data set, I mean the label and then the original imagery. So they simply ask whether it can be solved with machine learning or not. So that's why you need to know the limitation or the possibility of the machine learning first. And then I highly recommend you to read the theory behind machine learning, like how algorithm works. At least you need to like know how algorithm works for the some of the very like popular algorithms, for example random forest or k nearest neighbor. So you need to know how this algorithm works, what is the logic behind this algorithm. And of course you need to like start the data analysis with small data set first. You can do this with use of numpy and pandas. And of course you can like visualize the data set using matplotlib, which is the great library to like visualize data and also like do some plotting thing. And after that I highly recommend you to use popular machine learning frameworks, for example random forest, SVM, or k nearest neighbor. So you need to like know how to use these frameworks. Of course for the machine learning it's just the one step line. So with like just one line of code you can easily apply that algorithm and then generate the result or the train the model. So I'll show you in a minute about that. And then after that I recommend you to start the deep learning, but of course theory first. And to get start with deep learning I'll provide some of the resource later in the presentation. Okay, so then what about how to get help? Of course you can follow and subscribe my YouTube channel. That's where I normally like create lots of like GeoAI related videos. Also all the like content are related to geospatial development field. So also in the resource is to like buy deep learning application for earth observation course. It's available in Udemy, or you can simply search it through uh, Google search as well. And another very significantly helpful resource will be ChatGPT or GitHub Copilot, which are the great example of generative AI. And then let me get back to the water body detection from satellite imagery, the random forest work. So first of all let me tell you like how random forest actually work. So random forest works based on like the input features. So it uh, try to break the select the number of features randomly, and then it create the decision tree among them, and then it try to predict the result. For example in this case the first decision tree is it red, and then if yes uh, it's one tree, and then if no it's another tree. And then again it again try to find the feature if underlined, and if yes if no, and then maybe again if it try to see the color or the uh, is it one or zero or something like that. So yeah, based on that based on that kind of like decision trees it create the nodes, left node, right node, and then based on that it might have several like decision trees up to 50 or 100 number of decision trees. And then based on that tree structure it will try to predict the result. And all right, so in order to demonstrate these things, I have created the geospatial machine learning repository in GitHub. So if you found it helpful, then please start it. And here I'm going to demonstrate the random forest classification tags. Of course, I explain how the algorithm works, and after that, simply the first step is to like import the necessary packages, the NumPy, Matplotlib, and Rastrio. NumPy is for manipulating matrices, and then Matplotlib is for plotting your dataset, and Rastrio is to read or write the raster dataset. And then this Askelon is the great library which has lots of like machine learning algorithm and then pre-processing functions, so you can simply install it and then import it. And after that, you can like open your data set, rio.open data slash xtrain. This is my training data set, of course, which is also like available. I think it should be available somewhere here in the, oh sorry, I forgot to like put the data set. Of course, I'll show you in a minute like how it looks like later in the tutorial. So here I'm simply reading my data set. This is simply the Sentinel-2 imagery downloaded from Google Earth Engine, and I simply read the data set and then converted its shape. So right now it has like 6969162 comma 4. So 4 represent the number of bands, which is RGB and NIR band.
I In my case I use pre-existing shape file, uh, but yeah, you can feel free to use your own. And here is my dimension. And similarly, I have this X test imagery from different location, and I did the same, converted into the two-dimensional array, and then this is my water bodies on that particular location. And applying algorithm is very easy these days. For example, in case of, since I'm using random forest classifier, of course you can change this name, and then uh, your algorithm will be like very easily selected. And then based on this algorithm, I need to pass few different variables, for example number of estimator, and then random state, and other things, right? And I fit my model, and after that I try to predict based on X test dataset, which is just the satellite imagery. And then I also print out the confusion matrix. This is the matrix which represent the accuracy of my model. And talking about accuracy, my accuracy f1 score is 0.88, which is great. If the f1 score is near 1, then it's the great value, and if it's near 0, then it's the worst model. And similarly, after prediction, I again reshape my matrix into the number of rows column format. And then when I try to visualize it, so this is my RGB image, which is a little bit, I mean, a little bit gray and black, so it might be a little bit hard to see. But basically, the thing, this, you are saying a little bit white structure. It's the sediment, and then the river is flowing just between these segment. And this is my NIR band, and this is my ground truth. Of course, since I'm not using very good data set, that's why I classify these sediments as ground truth water bodies. But in the prediction, we got the water bodies most accurately. That means these are the water bodies, I mean the river channels, so far from that image. And this is generated from our model, right? So it's very easy. So as I said before, so there are few things. Okay, I want to repeat one more time. So in the machine learning, we do the input data cleaning and pre-processing. In this particular notebook, since I already did the cleaning and pre-processing, that's why there is nothing. And then I fed that data set into the model. In this case, it's the random forest model, right? And after that I do the prediction, and then check the accuracy, which was around 0.88. which is great. Then I predict the result. That means I do the prediction on different area. So yeah, that's how easy it is in the machine learning. And talking about deep learning, of course things might get a little bit complex than the machine learning one, because in deep learning, as I said before, there are so many parameters, so many technical terms you might not know, but I'll try to little bit s- make it a little bit easier. So here I'm importing the required things. Of course, I'm using TensorFlow. Instead, you can use PyTorch as well. And this is the same tax, waterborne detection, and then the same data set. So yeah, it's done in Google Colab. That's why you are seeing this Google Drive connection. And then I import my data set. This time I already converted my data set into NumPy format. That's why it's the same data set. So by saying here I have 442 tiles for the training image, and then the shape of image is 256 by 256, and then number of band is 4. Of course, it's RGB and NIR band. And then talking about the train YY initial, so it's just one. So that means we have only one band representing whether it's water body or not. And then in the text side, we have 280 imagery of same shape, and then output is a single band. And for deep learning, of course, we need lots of data. That's why I'm doing here data augmentation. That means I'm randomly flipping my image, or randomly cropping, or randomly zooming, changing scale to make it more. And then later when I do that things, my training data set is increased from 400 something to 1768. And after that I check the data set. So of course this is the same data, but I tiled those data set into the different number of tiles, right? And then here in the image you can see this is the river, right? And then this is the corresponding max. That means this represent the water body. And of course there might have some lake I'm not seeing, but yeah, this is the lake, and then lake or the some kind of water body. So we have this input data set, right? And then we fed into the model. This time the model might look a little bit complex than before, because in case of machine learning we have only one line of code representing model, right? And here we have like very large model. I'm not going to go into detail, but there are like convolution layers. And then we are using binary cross trophy. This is called loss function. And using that, and if I say the model dot summary, that here you can see it has almost 410 thousand parameters to train, right? So yeah, that means it's very dense model. Not that dense if we compare with the other deep learning model, but if we compare with the machine learning, it's dense. And then after that I do the like model dot fit. Of course fitting things we have to do it in the machine learning and deep learning both. And then I fed my data set into the model. And after that it will show you like how your accuracy is improving. and and if I plot the model loss function, of course it's not that great model. And then it haven't like learned lot from my data set, because as I said before, my data set is not that accurate. It contains the sediment as a water body as well. And that's why it should like start from highest peak and then it should decrease. But of course we are not seeing that pattern. That means our model is not learning greatly. And we did the prediction, and then based on prediction, so far what I found is this is our prediction, and then this is our test model. So that means we have few similarity here. right? For example, this is the river, and then river it's detecting, it completely ignored this part of the river. And then of course our river is predicted a little bit nicer way. Of course you are seeing these small chunks, these are the errors. And for this particular model I haven't like created the accuracy metrics, but of course this is not the operational model with high accuracy. But to increase the accuracy you need to like pass fed the like really good data set. And also you might need to increase your number of layers, or you can like a little bit change, play with your parameters, model parameters, to increase your accuracy. So yeah, deep learning is a little bit complex, but yeah, machine learning is very easy these days. Of course, to summarize this everything together, so GeoAI is the mixture of geospatial and artificial intelligence. And talking about second bullet point, there are so many methods and algorithms in AI, which can be time consuming. But don't forget about this flow chart. Always you need again I'm repeating this, you need input data set, clean pre-process, train the model, do the prediction, and if the accuracy is good enough, then write down your accuracy metrics and then do the prediction. Okay. And then another thing is start from theory behind the algorithm. I mean, at least you need to know which algorithm is best for like classification, which is best for regression tasks. Yeah. So that's all about the presentation. I am open for the question and answer session.
Thank you very much, Mr. Teksetri, for your wonderful presentation and demonstration. So we have few questions in our chat box. I'll read that to you. Maybe you'll answer that one by one. So there is a first question from
Yep.
Seraha Ekojenu, and will we give the dataset and the code?
Yeah, definitely. So for the code, actually I'm referring to the geospatial machine learning public GitHub repo. I'll put it in the chat as well. And then I'm referring to my deep learning GitHub repo, where I have shown lots of like thing. For example, land use land cover classification, swimming pool detection, building detection, land use land cover mapping, and then landslide detection, into deep learning and Google Earth Engine, and then flood mapping. So all of this code is available in this repo. And if you want to learn like step by step way, then I recommend you to buy this course. This particular repo is the part of this course, and I'll share this link in the chat as well. And for the recording, I think Lalit is recording the screen, so we'll upload it into the our YouTube channel OSGeo Nepal. Yeah.
Okay, thank you. So there is another question from Srishti Paudel, and she's asking, did you had your own training dataset? If yes, how many? Or you use some publicly available dataset? I missed that part due to the poor internet connection.
Oh, okay. Sorry for that. So the thing is, for the waterbird detection, so what I did is, so simply I searched for the water bodies in Nepal, and then I use maybe a file. I use this home data website. From this home data, I got lots of these channels, right? And then I downloaded the Polygon one. And of course, this is from November 2015, and someone like did this processing. That's why my data set is not correct, is not perfectly matching with my imagery. So I use this data set, I use this shape file uh, as my max. And then I use the Sentinel 2 imagery as my imagery, and then I try to get the like raster max using this shape file, and then did the processing. Of course, that's why my data set is not correct and my model is not that great, and then we cannot use that model in the production mode.
Okay, so there is another question from Anup Dahal Dai. So he's asking, did you perform gradient descent for cost function?
Uh, I actually forgot what I did because the code I have wrote. I mean, it's the very general like code I demonstrate for uh, the public talk, but yeah, I forgot exactly what I did.
Okay, so there is another question. How can we create our own mask layer of an image? So it's from Sarah
Okay, yeah,
Ekojenu.
yeah, that's a great question. Actually, to create the max, uh, this is the part where we consume lots of our time and effort. And recently, in my thesis work as well, I spent almost 3 months creating my max file. So, to create the max file for the geospatial data, I highly recommend you to use ArcGIS or QGIS softwares and then manually digitize those features in your imagery, or you can use the Google Earth Pro software where you get the very high resolution imagery. Of course, if your data set is time sensitive, then this might not be the great resource for you. For example, here, if I say Kathmandu and okay, it's moved to the Kathmandu, and now I can zoom in, and then I can manually digitize those building or digitize those roads, right? To digitize it, either I need to create polygon or the path, right? So basically, simply, for example, if you are digitizing any green areas in the city, then you might need to like digitize like this, and then save it, right? Save it, and then maybe later on you convert this polygon into the raster. But definitely, if your data set is time sensitive, for example, the park might have changed during the years, right? I mean, in few years, there might be there might be change in the park area, and then people might have used it for the different purpose. Then you cannot use Google Earth Pro software. Of course, in that case, I highly recommend you to go to like ArcGIS or QGIS software, or even the Google Earth engine. You can load your image and then digitize manually on that image, as I did here, and then save it as a vector file, and then later on you can convert that into the raster, if your task is segmentation. Or if your task is like object detection, then simply create the bounding box representing that particular feature, which is the rectangle of like minimum coordinates and maximum coordinates. So yeah, using bounding box, create your shape and then do the object detection task.
Okay, thank you, Mr. Drake. So there is one question from Barun Dai. He's asking, can a person who is not from geospatial background learn and work on GeoAI? Is it necessary to know everything about geospatial terms to work on GeoAI?
Yeah, that's a really great question. I thought the question would come from uh, most of the people might be from like geospatial domain, and then they already know about geospatial, and then how to dive into AI. My whole presentation was also in that flow, but the question is on the exactly opposite direction. That means if someone already know familiar with the concept of AI, then or the computer science, then how we can learn geospatial thing and apply geospatial thing, if I understand the question correctly. So the thing is, of course, in the GeoAI thing, so it's just GeoAI is just about data. So geospatial data, right? If you know the AI, if you are from computer background, then you might need to you might have already know like how to use Python or how to use mathematics in Python. That means NumPy, pandas in Python. And then also you might have everything understand expect the data, right? So the data thing is like, it's not that big deal. Of course, if you deal with other imagery, then the raster is also the similar, but with coordinate system, right? So we just need to preserve that coordinate system in the geospatial field, and then later, after the prediction, we need to apply that coordinate system. And of course, definitely, if you are already familiar with the terms, or with the like artificial intelligence thing, then definitely you can learn GeoAI very quickly. It's only about data, nothing.
Okay,
Yeah.
so we are running beyond the time, so I'll take two more questions. So first, I'll start with the question asked by Abhishek Adhikari. So he's asking, if I want to pursue my master's in GeoAI, what courses or universities would you recommend? So it's from Abhishek Adhikari.
Mhm. Yeah, it's a great question. Actually, to if you want to like explore the master in GeoAI, I haven't seen that course. Maybe there might be some courses related to GeoAI, but I haven't seen exactly the GeoAI masters. But definitely, if you ask me, so for example, in my case, I am the student from geoscience faculty, and then it's the Department of Science, right? But what I'm doing is I'm also exploring the GeoAI. I think the GeoAI is just the technology, or the tool that we utilize on the geospatial domain. Of course, if you go with the, like for example, geomatics engineering, or the s- uh, faculty of science, and then also sorry geoscience, or any field, you can easily apply that GeoAI thing. It's just the like a small branch of our geospatial field, I think. Yeah, it's up to you, how much you want to explore.
On top of that, Anup Dai has suggested Mr. Abhishek Adhikari to explore the course on Coursera. It's a course by Andrew Ng on machine learning, and maybe you can also refer to the YouTube channel with the name Three Brown One Blue.
Oh
And
wow.
yeah, another question is from maybe take sorry Chitish Dai, and he's asking, can you repeat the image used also in the demo?
Oh yeah, so for the image use in the demo, so my image is Sentinel-2 imagery, and I think it's from somewhere like Paschimanchal, and I try to detect the water bodies somewhere, maybe nearby Hetauda region. Uh, for the training, of course, my imagery is near Dang, I think, Dang or somewhere, and this imagery is just the RGB and NIR band, just the four band imagery from Sentinel-2, which is 10-meter resolution.
Okay, thank you. So there is a suggestion for you. I guess it's from Barundai, and he's saying that
Yeah,
please keep on uploading YouTube videos on geospatial knowledge. It is so informative. Uh,
yeah.
it's from Barundai. Uh,
Thank you, Varundai. Yeah,
yeah, I think it's
yeah.
8:11 now,
Amazing.
and we're I think done with
Yeah,
the question
before,
answer session. So
yeah,
if you want to
Lalit,
add something,
bef-
please go on.
yeah, sorry. Before you like end of this session, so I want to share the other resource as well. If you want to understand TensorFlow and deep learning, of course, first try to understand mathematics, a little bit of mathematics, and then machine learning first. And then if you want to do the deep learning, then I have a really nice course for you. It's the training lesson, TensorFlow for Earth observation training. And then this is really nice documentation. They went from like basic to advanced, so they have explained the uh, machine learning things a little bit, but they focus on the deep learning, and then they introduce Google Colab, TensorFlow 2, and Keras. And then this is really nice course. So if anybody is wanting to like learn the deep learning, then this course might be for you. So maybe you can like bookmark this course in your Chrome. So I already bookmarked this course, and yeah, it's great resource. feel free to explore it.
Okay, okay. So there is a last question from one of the. He's asking,
Okay.
most of the object detection are based on only three bands. What's the need of other bands? Will these extra bands cause workload in pre-processing?
Yeah, that's a great question. When I saw the models, mostly in the people who are not from geospatial field, for example, even in the image net, so lots of models are built on only RGB channel. But why we need the other channels is like, for example, in my case, why I use NIR band is, um, I know as a domain expert in geospatial field, I know the if I combine the red channel and NIR channel together and then do the NDVI analysis or NDWI analysis, then my water body is easily detectable in that image. I mean, using those indexes, I can easily detect my water bodies, right? So in order to like incorporate with the water bodies, so that's why I try to integrate NIR band in my channel as well. For example, I can drop the G and B channel and then only train on R and NIR channel, and I might get this similar accuracy metric on this imagery. So it's up to you. If you are like little bit know about the domain, then you can integrate. For example,
Yeah.
here I
Mm.
also can integrate the DEM dataset, which is digital elevation model, and then of course river or water body found in lower elevation, right? And then it will be significantly great learning curve for the model. So if i if I use the DEM dataset here in
Yeah,
my,
so I
yeah.
think we are running out of time. So there is another question from Muhammad. He's asking, I want to apply GeoAI in the field of healthcare, especially maternal and child health. What steps should I follow as a beginner?
Yeah, I think I exactly don't know much about like healthcare system. For example, maternal and child health. I don't know what you want to do with GeoAI. GeoAI is just the term which deal with geospatial data and apply the artificial intelligence. So I repeatedly saying that multiple times. But for the child health, maybe if the task is about like mapping the child health case, for example in Nepal, there might be lots of issue related to like lots of issue related to health might be in the western part of Nepal, right? So if you are like want to contribute on those particular things, for example, you can map out or detect the hospitals from imagery, or or maybe you can detect the you can do the analysis how far is school from individual homes. Those things can be done. I don't know the exact answer for that.
Okay, so I think we are almost done with this session. So if there is any question, you can drop in your in our chat box, or maybe you can ask yourself. I think this is it for today. So it was a great session to know a lot about GeoAI, its possibility and constant, and a kind of roadmap also. So from the team of West Nepal, and from my personal side, I'd like to thank Mr. Tej Chitri for his great presentation, great contribution, and for everything. So thank you everyone for joining this session, and I'd like to let you know that we have another session in few days. So feel free to join that also. So again, once again, this is a technical session where we talk about the data, and especially geospatial data and geospatial software and many more. So this is a combined effort from the Voice Nepal and NGS. And again, thank you everyone, and I wish you all the good night. Thank you.
Thank you.